All right. Good afternoon, everybody. Good to see you all here. Hello, Russell. Good to have you here. So, same idea. We're gonna wait 5 minutes for people to come in. Hello, Matt. Good afternoon. And once I see that more people have come in, we're gonna get started with our lesson. Okay. Good afternoon, Amir. Good afternoon, Camilla. So we're still waiting on more people to show up. Good afternoon, John. Looks like these are the 5 people that are here. John, Camilla, Amir, Mac, and Russell. So we gotta wait 4 minutes until more people show up. Hello, Anna. Hello, Chris. Good to have you join us. Hello Har, hello Hans, good to have you join us. So for those of you that are tuning in, please have this page open here. You'll see coming up on your screens very shortly. This is page 5 of Unit 4 workbook. So please have this open. We're going to start with this. Okay? And then we'll continue from there. Hello, Rose. Okay, so let's talk first differences here. So let's talk about what we learned yesterday. Remembering that first differences, right? We subtract the bottom from the top. So of course there's no space here. If you don't have space to write first differences here, you kind of connect them with two lines and then you do the math in between. So here it would be 4 minus 2. So that would end up with 2. Okay, with the next two here, 8 minus 4 is 4. And we can stop there. We can already see that these first differences are different, which means this must be nonlinear. Okay, so that's nonlinear. This one here, going through, we go 2 at a time. 3 minus 1 is 2. 5 minus 3 is 2. 7 minus 5 is 2. 9 minus 7 is 2. And so these first differences are all the same, which means it is linear. And our third one here, going through, 4 minus 5, okay, is, 5 minus 4 is 1. 6 minus 5 is 1. 7 minus 6 is 1. 8 minus 7 is 1. Okay? And so we have that as linear. And yes, these numbers should be consistent actually, sorry. So I want you to cross these numbers out. Should have caught that earlier. It's meant to be 1, 2, 3, 4, 5. Here. Because we need a consistent x. If it changes, it's not linear. So it's consistent. We want it 1, 2, 3, 4, 5. Okay. So that was basically what we talked about yesterday. Right? With first differences, we said we subtract the bottom with the top for every 2 rows. And if they are all the same, it is linear. If they are different, it's nonlinear. Okay? So that was our way of quickly figuring out whether something is linear or nonlinear without graphing it. So if we continue onwards here, right? So let's do it yourself. Let's do these 3. I'll give you 3 minutes, 1 minute for each. Quickly calculate the first differences and tell me, is it linear or nonlinear? So is it linear or nonlinear? Okay, so 3 minutes on the clock. All right. So hopefully, let's first make sure we're on the right page here with the full answers here. Should be linear, nonlinear, and linear. Okay? Should be linear, nonlinear, and linear. Now if you got something wrong from this list, let's go through the first differences. Okay? 4, 4, 4, 4. So that should be pretty straightforward here. This one will be 4, and then all of a sudden 12, and then 20. So that's clearly nonlinear. This one here, you have to be careful. The third one here. So negative 2 minus 1 is negative 3. Negative 5 minus negative 2 is negative 3. Negative 8 minus negative 5 is negative 3. And negative 11 minus negative 8 is negative 3. Make sure you don't just pass this. It's like, oh, Mr. Choi wrote it's negative 3. It must be right. No, do it yourself. Make sure you get negative 3. If you don't get negative 3, what's the point? You're doing the math wrong. You're going to get it wrong on a quiz or a test. There's no point just watching me write down negative 3. Try it yourself. Do you get negative 3 with your own calculations? Okay, if you don't do it yourself, you're not going to get it right later, because this is where everyone has troubles, especially when the y value has negative numbers. Okay, so number 3. Okay, Jay gets paid $8.50 per hour. Complete the table of values on the right. Calculate the first differences. So if it's $8.50 an hour, then for 2 hours, it's $8.50 plus $8.50. Which would be $17. Then another $8.50 would be $25.50. Right? And then another 8 after that would be $34. And then another 8 after that would be $42.50. Okay? So, is this linear or nonlinear? Well, if we calculate the first differences, we should get $8.50, right? It's constantly going up by $8.50, which means this must be linear because the first differences are the same. Okay, so make sure you understand what's happening here. But you'll notice this $8.50 matches here, right? Saying that it's $8.50 per hour, then it's pretty obvious that since we know the pattern of how much it's going up per hour, right? We're adding $8.50 every time. We should know already it's linear before it even asked us, right? So what's the relationship between the first difference and Jay's rate of pay? They are the same. Right? This number is the same as these numbers here. Right? As it should be. If we're saying it goes up per hour, that's our pattern. That's our linear trend we're talking about here. And we'll dive into a little more detail on today's lesson. Okay? So, this is review of what we did yesterday. If you don't know or you're still having trouble with this, I highly suggest you finish off the page 4 homework. Okay? Well, let's go into today's lesson. 4.2, rates of change. Okay? So let's try calculating this stuff here. All right? So, we have here rate of change, the change in one variable relative to the change in another. And for slope, a measure often represented by m, by the variable m, of the steepness of a line, the ratio comparing the vertical and horizontal distances, called the rise and the run, between the 2 points. Okay, and we'll look into detail. So this is our new thing. This is what I was kind of constantly reminding you and telling you that it was coming. This is that big bulk of our course. So y-intercept is the value of the dependent variable when the independent variable is 0, sometimes called the y value. Actually, yeah, y. And there's another letter that people use for it. It's also called the b value. Y/b value. Okay? For the x-intercept, the value at which a graph meets the x-axis. And the value of y is 0 for all x-intercepts. Okay? And then, of course, a linear relation is a relation in which the graph forms a straight line. Okay? So let's talk about these three definitions. Let's not just say them and then move on. Let's really talk about what we are trying to say here. Okay? A y-intercept, the value of the dependent variable, and the dependent variable is our y variable, when the independent, our x variable, is 0. And then we call that the y value or the b value. Okay? The x-intercept, the value at which the graph meets the x-axis, and the value of y is 0. So that would be here. Any point that's on this axis here would be called the x-intercept, which means for the y-intercept, it's anything on the y-axis. And for a linear relation, a relation in which the graph forms a straight line. Okay? So let's try to figure out what rise over run means real quick here. Okay? So rise over run, let's draw 2 points on this graph here. If you don't have this, don't worry. We have another page to kind of practice our work here. But let's work with rise over run here. We'll pick a point here. And then we'll pick a point there. Okay? So we'll pick these 2 points. Right? And let's assume that these points are on one straight line. Okay. So they're on one line here. What you do to calculate the rate of change or the slope, okay? We follow something called rise over run. Okay? And this is how that works. When you have a graph with 2 points and each point is going up by 1, you're going to draw this imaginary triangle right here. So you're going to connect the 2 dots with a triangle and kind of forcing a line there. And so what you're going to do is first you're going to count horizontally how much you go to the right. So you always start from the very left, right? The left furthest point, okay, which is this one here. So the left furthest point is where we start, and we're going to the right. So we start from here, we go to the right, and we count how many squares. So 1, 2, 3, 4, 5. So this would be 5 squares across to the right, and then this would be 1, 2, 3, 4 up. Okay? What we write down for our slope up here is going to be our run is 5. Our run, we run on a straight road, right? If we see someone running, they go left to right. Okay? You don't run up a cliff. Okay? We don't do that stuff. We just run left or right, and so that's a way to memorize it. But we're always going to go to the right, which means our run value is always going to be positive. Okay? The rise value can be positive or negative depending on whether you went up or down. For us, we went up to the next point, which means it would be positive 4. And that would be our slope, our rate of change, 4 over 5. Okay? So let's get some more practice with this rate of change one here. Let's get some more practice with this one. We have some more things here. Let's determine the slope of each object. Okay, so this one here, real quick, rise over run. And we use the letter M to indicate slope. So M is equal to rise over run. So what is my rise? Well, it's the up and down portion, which is 4. And our run is our left and right, which is 28. Now, when you write this fraction, if you can simplify it, you must simplify it. And you can go step by step for this. So I can go 2 over 14 into 1 over 7. Okay? And so that would be my answer. My slope is 1 over 7. Okay? For this one here, 500 and 2,000. So rise over run again is 500 on top and 2,000 across. If we simplify that, we get 5 over 20, or in other words, 1 over 4. Sorry, that did not fit. So 1 over 4. Okay? So this is pretty simple, right? This is pretty simple. So we are easily able to calculate these things here. Okay? So let's continue onwards with the next two. Okay? Rise over run. These ones I've already shown you. See how I've created that right angle triangle. I've created the triangle. I've written down how many squares across and up. So all you have to do is copy it down. What's my rise? It's 2. What's my run? It's 10. And you can't really stop there, right? You can't stop there because we have to simplify. If you don't simplify, you lose marks. You have to simplify. You're going to lose half a mark for not simplifying. For this one here, rise over run is 3 over 2, and we leave it like that. Okay? Because we can't simplify this one, right? So some of you are probably thinking, wow, that's pretty easy. We just have to count squares, easy, done, simple. Yes, but these are all positive numbers, right? So don't think that it's always going to be this easy, because once we start sticking negative numbers, people start freaking out and start getting things wrong. Okay? So let's start with the easy stuff to make you feel comfortable, and then let's move into the harder stuff. So this is our last page for today. Okay? I'm going to give you 3 minutes once again to finish this whole page. Give me the slope for each of these 3 lines. Okay? 3 minutes. We'll take it up, and then that's our lesson for today. Okay? So you got 3 minutes. On your marks. Go. All right, let's take these up. So you'll notice I didn't give you any points. All right, so you have to pick any 2 points that you would like on this line. Make sure the points that you're picking are points where the grid lines cross. So the points I would have picked are there, there, or there. Any of these, 2 of these 3 points would have are what I would have picked. Okay, I've just drawn them huge for scale so you can see. Doesn't matter which 2 you pick, you should get the same slope regardless. So let's just pick the large one. Okay, just this one here. I'm going to draw my right angle triangle. So we write rise over run. We start with our run first, right? Our run, which is our left to right. So starting from this point, left to right, 1, 2, 3, 4, 5, 6. 6 to the right. Okay, we write 6 down. Okay, then our run, our rise, 1, 2, is 2 up, so it's positive. So we're gonna write 2 on top, and we're gonna simplify this fraction. You should get 1 over 3. Okay, so that's for A. A is 1 over 3. Now, even if you did it with this one here, you'll notice it's 3 across and 1 up, which will still give you 1 over 3. Okay, so it doesn't change anything here. Question B. Picking our points. You have a lot of points you could pick. So you have a whole bunch of points here that you can pick from. Okay. So there are 6 different points you can pick. Even the one down here works. So if I were to pick 2 here, let's pick this one and this one. Okay, so we have this. Okay, we have our rise over run. So from here, we start from the leftmost point, whatever leftmost point you have, right? So we're gonna follow that line. 1, 2, 3, 4, 5, 6. We go 6 down. So this is now downwards by 6, which means it's negative 6 on top. Then we run 1, 2, 3. We go 3 to the right, so it should be negative 6 over 3. If we simplify this, you should get negative 2 over 1, or just negative 2. Okay, so there we have this one here. Okay, and our last one here. If we were to pick points for this one was a little tricky to pick your points. Okay, we have 1 down here. We have 1 here. And we have our last one here. So only 3 points to pick from. Nothing in between work. If you picked a point in between, that would not be correct. That's technically not on the grid line. That's technically not on the grid line. So make sure you pick your points carefully. Okay, so it's one of these 3. So I'm just going to pick this one down here. I want to make a smaller triangle to work with. Okay, so M is equal to rise over run. For here, we're doing our run first. So 1, 2, 3, 4, 5. 5 across. So we put that at the bottom. And 1, 2, 3 up. So we get 3 over 5, and we cannot simplify that any further. Okay? So with that being said, that is the end of today's lesson. We'll be continuing on this tomorrow, and tomorrow there will be more practice problems. So this was a quick 20-minute lesson to get you comfortable with rise over run. And you'll notice that 4.2 continues on tomorrow. So please come to class tomorrow. I think I'm just going to remove office hours and make lessons a little bit shorter and just do a lesson every day, because not many people show up for my office hours right now. So just assume that we have class every day, and the lessons will be shorter. So it won't be as long. We're going to try to keep it clear and concise. Some lessons might be longer, some lessons might be shorter like today, but we're going to try to keep it every day as best as we can. And of course, if I say there's homework, there will be homework. But for today, there is no homework. So you're lucky you don't have any homework today. Enjoy the rest of the day. Do your other classes. Focus on your other classes. But otherwise, that is it for today. Make sure you're here tomorrow to continue Rate of Change lesson, and have yourselves a good one. Peace out.